Sanibonani abafundi. Welcome to this video. And the purpose of this video today is to wish you a very happy Pi Day. Now, you might be wondering, what is that all about? Well, the Americans write the date month, day. So today is in fact would be described as 314, which are the first three digits of Pi. Here at SIMI, we thought it would be appropriate to share some ideas about Pi with you. Some of them you may know, some of them you may not know. So if we've got a circle with a diameter of 1 and it rolls one full rotation, it will roll a distance of exactly pi. Pi is the number of times greater the circumference of a circle is than its diameter. The first thing that a lot of people kind of mistake pi for is they think that it's 22/7. Pi is not 22/7. In fact, 22/7 is what we call a rational number. It's a ratio of two whole numbers, 22 and 7. And rational numbers always either end or they repeat. But if we look at 22/7, we can see it repeats. It actually repeats in patterns of 6. Those digits after the decimal point, 1, 4, 2, 8, 5, 7, they keep on repeating. 22/7 is a rational number. The symbol for rational numbers is a Q, right? We'd say that 22/7 is an element of the rational numbers. Pi is an irrational number. The symbol for irrational numbers is a Q with a little dash, okay? So pi is an element of Q dash, irrational numbers. And irrational numbers cannot be written as a ratio of two whole numbers, and they never end, and they never repeat. So what we've written down for you here are just the first few digits of pi. You might say, well, there's thousands of digits there. Yes, there are, but pi never ends and never repeats. So we could never write down all the digits. One of the things you might be interested in is how good an approximation is 22/7 for pi. Well, the way we work out an error is we work out the difference between our approximation and the real value. We divide that by the real value, okay, and then we multiply by 100 to make it a percentage. So 22/7 is a little bit bigger than pi, so the difference divided by pi times 100, and we get 0.04%. So 22/7 is a really good approximation for pi, but it's not pi. Here's another interesting fact that you might not have known, but if you take the reciprocals, in other words, 1 over the square numbers, the perfect squares, so 1 over 1 squared plus 1 over 2 squared plus 1 over 3 squared, the more of those you add, the closer and closer your answer will get to pi squared over 6. So if we were to add hundreds of these numbers up and then multiply by 6 and then square root our answer, we'd get a really good approximation for pi. The more numbers we add up, the more of those fractions we add up, the closer our answer will get to pi. The other way that we can approximate pi is by playing darts. And you might say, how on earth? Right? But if we picture a round dartboard mounted onto a square board, okay? Now, if the square's got a side length of x, then obviously the area of the square is x squared. The radius of that circle will be half x, so its area will be pi x squared over 4. Now, if we were to randomly throw a dart at that board, not aiming for the round part, just aiming for the square, randomly, all right, then the probability, the chance of it landing in the circle would be the area of the circle divided by the area of the square. And that comes to pi by 4, right? So if we could randomly do that thousands of times and see how many of our darts land in the circle as a proportion, that should start to approximate pi by 4. Remember pi by 4? We're going to look at it now. Okay, so what we've got over here, we've got an Excel spreadsheet. We've got a picture of a dartboard, and it's actually on an axis, a system of axes with 0, 0 at the bottom left corner, 500 at the top right corner. Okay, and what we are going to do is we're going to get Excel to generate a random number, a random x value, and a random y value, both between, so here's the command, rand between 0 and 500. Okay, and so we end up with 78. We're going to paste that in as the y value. So now we've actually got a point that has been plotted. It's been plotted at 337353. That happens to be a hit. It's in the section saying 18. If we were to press F9 key, oh, nearly a triple 20 there. Okay, what we're going to do now is we're going to calculate using our distance formula, because the middle of the board, the bullseye, is at 250, 250. We're going to calculate the distance of our point from that point. So in other words, from the center. So minus 250, we're just using our standard distance formula from analytical geometry. So we take the difference in the y value and 250. We're going to square that, and that there's the distance. Now we're in the triple 18 there in the little red sector, and that would classify as a hit. Inside here, just in case you're interested, we've got just a thing saying that if it's bigger than 250, it's a miss, otherwise it's a hit. Right, now the nice thing about Excel is that we can copy those things down, right? And now we've got 2 throws of the darts. In fact, we've got 1 hit and 1 miss. And remember that the proportion of darts that hit is pi over 4. If we used that very small data set of 2 darts, we would get an estimate for pi of around 2. Okay, but the cool thing with Excel is that we can copy that down. Let's just throw 10 darts in the first instance, okay? So there we go. We've got 10 darts. 7 of them were hits. 3 were misses. And if we use that proportion, that 0.7, as an estimate for pi by 4, then we get that pi is 2,8. Now the cool thing is that we can actually copy this down, and we can actually throw, in an instant, we can throw 10,000 dots. So there we have 10,000 dots thrown at that dartboard. Of those 10,000, 7,834 hit the board, hit the circle, and the rest were outside. And if we use that 0.783 as an estimate for pi by 4, then we get an approximation for pi of 3,134. Not too bad. Let's just throw those dots in 3,151, right? Slightly less, slightly more. If we did this tons of times, and we averaged our answers, we would actually end up with a very, very good approximation for pi. So we hope you found those few facts about pi interesting. We hope you have a wonderful Pi Day, and we hope you have a wonderful weekend. Vi ben en person to edge.